So the last part of our demo on coding for the Circuit Playground Express is going to be on how to use the switch and how to do some animations with the neopixels using for loops, which is our final core coding component. And just like we've done with some of the other examples here, I'm going to add some comments to sketch out what I want for the code. So here I'm going to check if, just going to check the switch state, whether the switch is on or off. And then I'm going to run a neopixel animation if it's on. Now, to use the switch like I've done with the buttons, I'm going to need to set the pin mode for it. But I don't remember what the switch is called. I'm going to check the reference for that again. And I talked about in the last video how there is not a easy reference for these library things. I could look in the example and probably find something, but I'm going to show you another way, which is go to the actual library itself. So if I go to the GitHub repository for the Adafruit Circuit Playground, I can find some more information about this library. And it's got the function calls here, but it doesn't have like a list of the predefined terms, but I can find those easily enough if I look in the header files for the library. So if I go in here and then right towards the top, there's going to be all these defines, right? Hashtag define, where it's defining all these constant numerical values for things. So we can see like the C play left button here. Now we need to check and make sure we're looking at the right board, right? Because here's some AVR. There was an older version of the Circuit Playground. They used a different chipset. So I know the neopixel for the current one is on pin 8. So that's where I'm going to look. I'm looking for the switch. I could also do a command F. And here we go. It's C play slide switch pin, which is 7, and I can check my board. Yes, D7 is what that should be, so that's the name. C play slide switch pin. That is very long, but we'll go with it. So pin mode, C play slide switch pin is going to be an input. I think that also has a pull down. We'll see. Switch. All right. So now for our animation, I am going to just do like this. This one can be easier than what we were doing with the toggle, because we're not trying to turn like a momentary thing into a toggle thing. The switch will in fact keep its position, right, once it's set. So I'm going to say if digital read, what was that? Slide switch pin is true, run my animation. Otherwise, don't. And we can try I'm going to show you a bunch of different animations here. I'm going to ask you to do something that's completely different from what I've done, right? So make up your own animation sequence. But I'm going to show you some strategies that you can use to do that. And to do an animation, we're going to use the for loop. And the for loop is a way to do something over and over again with perhaps just a slight incrementation to it. So let's just see how this goes. So I'm going to start out with 4. And the for loop, I need to give it a counter, like an index. I need to give it the starting state of that index. The condition that I'm checking, like I want to count from 1 to 10, so I'm going to like increment my index 1, 2, 3, 4, 5, right? But I need to check if it's 10, then I want it to stop, and then what I want to count by, how much I want to count by. So am I doing, like I just said, counting by 1? 1, 2, 3, 4. Am I counting by 2? 1, 3, 5, 7, right? I can count by multiples of 10, whatever I want. So I have to declare my index. The tradition is to use the variable called I, and then I separate these 3 things out with semicolons. So I say int I, but I have to initiate it, right? Equals 0. We're going to start at 0. We're going to count up, and let's go less than, well, I is less than 100. So we're going from 0 to 99, really, there. And then our increment will do 1. So I could say I equals I plus 1, or I could just say I plus equals 1 is the same thing. Plus equals being like take this and add 1 to it. Or from C++, we have just plus plus, which is take this variable and add 1 to it. So that's what I'm going to do. Okay, so that's the structure of our loop. If I want to see that this is working, we'll do a print ln I. So we can just see that, and I should get 0 to 99. That's what I'm expecting when the switch is flipped. All right, reset. Try again. Okay, and the serial monitor. Here, so we've got nothing, and now I'm going to throw the switch. And then let me stop the switch. Okay, so there we have it. There's our sequence. 0 to 99, as I would expect. And you'll notice that it's giving me 0 to 99 several times, right? Because as long as that switch is flipped, it's going to do this. 0 to 99, 0 to 99, 0 to 99, 0 to 99, over and over and over again. That gets to our, state change thing from above. But in terms of an animation, that's like what we want, actually. We want it to go repeatedly to when it stops, just start it again, like a looping GIF. Okay. So that's fine, but we actually want to do something with the neopixels. So let me grab one of the neopixels from up here. And I am going to, for the first animation I'm going to show you, I'm going to change its color. I'm going to say, for the red value, I want that to be I. So the first time this loop happens, it's going to be 0. By the time it ends, it'll be 99. So we'll see some red value. And then I'm going to do the opposite here. I'm going to say, okay, start at 99, but minus I for the blue value. So the blue value will start on and will slowly dim, whereas the red value will start off and slowly come on. Now I say slowly, as we saw, this happened extremely fast, right? So if I want that actually to be slowly, I have to tell it to be slowly. And I'm going to put a delay in here, right? So if I wanted to make a 10-second animation, and I've got 100 steps in my for loop, then I would need each step to be a tenth of a second. Right? Yeah, because then if it's 100 steps, that's going to be a total of 10,000, which will be 10 seconds. So this will take 10 seconds to fade this LED's red and blue values when I throw the switch, and then it will restart the animation when it loops. So there, it's looking blue. Might be a little hard to see with the camera, but now it's kind of orangey yellow, and then it resets. And there it gets to that yellowish. And so that yellowish, we're seeing that yellowish because I've got this 30 on the green there. It's not going fully red because the green is mixing in to the value of it. But that's great. The problem is now if I stop the switch, the animation is going to complete its loop, right? So even if I throw the switch, because this is taking 10 seconds to go through, like if 5 seconds into it, I flip the switch off, it doesn't know that. It doesn't know that because the animation's running. So that's a downside to using delay, right? Because the delay, particularly delay in a for loop, you have to wait until it's done for the code to continue running. The code goes line to line. So we will look at interrupts or ways to use millis to add delays into our code in a non-blocking way later on in the semester. But for right now, it's fine that when we turn the switch off, we have to wait for the animation to stop. But that pixel is left on there. So I might want to add something like clearing my pixels when the loop is done, but still within this if statement. Okay. All right. Let's look at another animation. Okay. So I'm just gonna I'll just take this out. And I'm going to change this a little bit. I still want to start at 0, but this time I'm going to say, well, I was less than 10. So I'm only going to count 0 to 9, and I'm still going to increment I by 1. And here, I'll put back in one of these, but let's see what else I can do. So I used just the straight I and the 100 minus I. This time, let's do on the red, let's do 10 times I. So the first time and through the loop, it'll be 0. And then on the last time, when it's 9, it'll be 90. So we're adding the red back in, but in bigger chunks. And this time, too, I'm going to say, I want the LED number to be I as well, because I'm counting from 0 to 9. There's 9 LEDs. That's great. I could do a count of the LEDs here. And just so we can see what's happening, we'll add a little delay in here too. This time we've got only 10 steps. So if we want a 10-second animation, we do a 1,000 millisecond delay. And then they'll turn off when we're done. Let's see. Okay. And I throw the switch. And you can see one by one, the neopixels light up, and they're becoming more magenta as we go. And then it starts again. Great. If I turn the switch off, the animation continues running. It completes, and then it doesn't run again. Perfect. That's another kind of animation I could do. I'm going to show you one more in that sort of combining the two of these and doing some other fun stuff. Okay, I'm going to leave. What am I going to do here? I want to do something a bit complex. I want to do both of those two things, right? I want to gradually or no, I want to show myself which LED is numbered what. So I just had them go on in a ring. That was fine. I want them now to blink based on which number they are. So I want this one to blink once, this one to blink twice, 3 times, 4 times, etc. as we go around the loop there. So to do that, I'm going to have a loop within a loop, right? And this is where the programming logic can get a little complex. So this worked for going around the ring. And then within that, I want a loop that's going to let me blink each of those LEDs. So I'm going to say I need another index for this loop, and I want to make sure that I use a different variable. If I'm nesting loops, I want different variable names, so I'm just going to call this one J. And J let's just see here. J is going to be 0. Well, J is less than 10 as well, and then J plus plus, because I want the first one to blink once, then twice, etc. And to do the blink, I'm going to have the LED come on. I'm going to delay for some period of time. And then I'm going to have that LED go off, right? And so thinking again, the individual LED off is just 0, 0, 0. Let me make this a little bit longer. Okay, so it'll come on for half a second, stay on, and then off for half a second. And let's see. Let's just see if I'm on the right track here. I guess I don't need that delay down here. And I'm going to have an error anyway, so let's reset. And try to upload again. There we go. And just so we're aware, like our other buttons still work, which is great. So we'll throw the switch. Okay, interesting. That's not what I was quite expecting, right? I was expecting the first one to blink once, and then the other ones to blink twice. So what have I done wrong here? Well, I've used the wrong index to determine which LED I'm blinking on and off. I'm using this loop. So this loop, I is going 0 to 9, and then J is going to 0 to 9. So J is going to do its full 0 to 9 sequence on this LED. That's what I want. That is what I want. Yeah. That's it. Okay. So yeah. So I mean it's doing exactly what I'm telling it to do. I want this one to do 1 blink, 2, 3, 4, etc. Increasing numbers of blinks. Right now, each LED is doing 10 blinks because that's what I'm telling it to do. I'm saying go through the index LEDs, which is I, and then blink 10 times, right? If I change this to 5, now it's going to do the same thing, but each LED will only blink 5 times. If I change it to 3, each LED will only blink 3 times. Let's take a look. So this is where I might want to make some comments. This is the neopixel index, and this is my blink index. And I had left the switch on. 1, 2, 3. 1, 2, 3. Great. So here's where we can get interesting with our loops, that they're nested. So I can say, instead of saying j is less than 3, what if j was less than I? Okay, so now when it runs, the first time through this loop, I is 0, j equals 0, is 0 less than 0? No, it's not going to do anything at all. Then I becomes 1, okay, so j 0 is less than 1, so this will do once. And then I becomes 2, and we go in here, and j 0 is less than 2, so this will happen twice. Okay, so let's see what that does. Three. Great. So now it's almost doing what I want, except if you noticed, this first one is not was not on, because as I showed, when it's 0, that index 0 is not greater than 0. So here's where I have to get a bit funny with the counting, because I want the blinks to really be 1 through 10, right? I really want both of these to be 1 through 10, but my index I know is 0 to 9. So I'm gonna change some of my ranges here to try to get that first LED to line up. So I really want J to start at 1, and I want I to start at 1. And this time I still only want 10, but I want 10 to be inclusive, right? So I'm going to say less than or equal to 10, and same here. Well, j is less than or equal to I. So now these will both be ranges 1 to 10, inclusive of 10. But for my index, this still has to be 0 to 9 for the indexes of the LEDs, so I'm going to say I minus 1. So when it's 10, it'll actually be 9. When it's 1, it'll actually be 0. Let's see that. Okay, and that first LED did blink. That's the third one. There's 3 blinks. There's 4 blinks. Great. So I've got my blinking happening the way I'd like it to. The last thing I'd like to do, though, is it's taking significantly more than 10 seconds, right? Because of the quantity of blinks is increasing each time. And I've got it on like it takes 1 second to do a full blink. So what I'd like to do, I'd like each LED to have a second's worth of time, because there's 10 of them. But I'd like to change the speed at which they blink so it fills that second. So I am going to take my delay amount here and divide it by the index of the LED that I'm on. So the first one is going to be I. Second one's going to be I. So now my first LED, 500 divided by 1 is 500. It's going to get the full second for its one blink. My second LED is going to be 500 divided by 2, 250 for each, the on and the off state. That's 500 total for one blink, but it's going to blink twice because it's the second LED. So that's also 1 second, right? Go, etc., etc. This will make each blink still be, or each LED get a second worth of time, but their blinking speed increase to fit into that time. This is also why I had to change these ranges to be 1 to 10 inclusive, because if I tried to divide 500 by 0, right, that's an error. That's not math that can happen, and my program won't run. We can try. Will it let me do that? It will. What's going to happen? It stops. Okay, this is tricky because, as you saw, my code compiled, and now it's giving me an error because of the serial monitor, I think, is hanging because the code on the circuit playground shut down. It can't deal with divide by 0, right? So I want to make sure that's not 0. That's why I used the number ranges 1 to 10. Let me reset the board. I'm going to double click to put it in the bootloader mode because I really made it sad with that divide by 0. That was weird. Looks like it went through, but it still gave me no device. But it seems to have worked. And now you can see 2 blinks, 3 blinks, and the blinks are getting faster and faster as they go around until it's almost like a blur at that last one. Very cool. So, and if I turn the switch off, oh, I just missed it. But that animation should stop. And then we're done. Nice. All right. So that's looking at loops and some of the logic of loops and how you can use those to run a animation sequence on the lights. Again, I want you to do something different from what I've shown there. How you make it different is up to you.